In my last video, I talked about the standard normal distribution. In this video, I want to talk about how to apply what we learned last time to any normal distribution. Remember, the reason for this channel is to help you pass your math class so you can achieve your goals and get a better life. Applications of normal distributions coming right up. We have a procedure when we encounter a non-standard normal distribution. You should draw the normal curve, label the mean and any x values that you find, and then shade the area appropriately or shade the region. Then we have to go through a process where we change each x value to a z-score. Then use technology, we'll use a calculator to find the area, which is the same as the probability for the shaded region. When we use the formula z equals x minus the mean, all divided by the standard deviation, what happens is we transform any normal distribution, we move it, if you like, to make it the standard distribution. In this example, the employees of Wahoo Corporation have a normally distributed salary structure. The mean is 60,000, so the average person makes 60,000. The standard deviation is 7,500. What proportion of employees earn 20,000 more than the mean, so more than 80,000? In this problem, we are looking to find the probability that x is greater than 80,000. And if I'm going to put this on my diagram, 80,000 is here. So the probability that x is greater than 80,000 is this area right here. The mean in this particular case is 60,000, and I don't see the standard deviation 7,500 on my graph. But I'm going to use my formula here to change x into a z value. So x is 80,000 minus 60,000 all over 7,500. And when I do that calculation, I see that x is, when I round it off to two decimal places, z becomes 2.67. So that actually has the effect of changing x into z. And now that I've done that, I see that z here is 2.67. Here's my standard normal mean of 0. And now I've changed my problem into finding this area. And the problem itself now becomes, I want to find the area above the z value 2.67. And we'll do that on our calculator. Working this problem on my calculator, I have second distribution. I'm going to go down to normal CDF, and I want my lower value to be 2.67. I want my upper value to be effectively infinity, and remember we have a special way we have to simulate infinity on the calculator. We do 1 second EE and then 99, and effectively that's a huge number. We leave the mean at 0, we leave the standard deviation at 1, go down to paste, hit enter, that puts it on the home screen, enter again, calculates it, and you can see there that what I found on my calculator is that the probability here is equal to 0.0038 when I round off to 3 decimal places. We can actually even use the calculator to do this calculation without shifting this to standard normal. And that could work as a check. So this is a second way, a different way to work the same problem. Second distribution. And I'm going to go down to normal CDF. And my lower amount I want as 80,000. I'm going to leave my upper amount as infinity, so 1 second EE99. Now I'm going to put in the normal distribution, not the standard normal. So I know the mean is 60,000 and I know the standard deviation is 7,500. And you know what's happening actually inside the calculator? It shifts it to standard normal and then does the calculation. And we'll get the same calculation. It's slightly different rounding though. So now we have this equals, the probability equals 0.0038, which agrees to 4 decimal places with what we found when we shifted it to the standard normal distribution. Next we'll consider how to compare two different tests. So we have student 1, Jane, and she takes a math test. The mean of the math test is 63, standard deviation is 7, and Jane makes 73, so X is 73. Now Carol takes a biology test. The mean is 23, standard deviation is 3.9, and Carol makes 26, so X is 26. Who did better on their test? So the way to work this, of course, is to calculate the z-values. That shifts everything to the same distribution so we can do a proper comparison. So when I calculate Jane's z-value, her score 73 minus the average or the mean 63 all divided by the standard deviation, that's 1.43. So the z-score for Jane, I'll just say zj here, is 1.43. The z-score for Carol, when I make that same comparison, is 0.77. Now it's pretty clear that the z-score for Jane is higher than the z-score for Carol, so the student who took the math test, Jane, did better. Jane did better. I would like to invite you to like this video and subscribe to this channel. Thanks very much for listening.